Hey there, welcome to this course on GitHub Advanced Security, where you will learn how to tackle real-world security scenarios as part of your DevSecOps and secure software lifecycle management. My name is Peter Detender, a lead technical trainer here at Microsoft with a passion for DevOps, or should it be better said, DevSecOps. In this specific module, we continue exploring the GitHub Advanced Security suite of security mechanisms where, after touching on Dependabot in the previous video, this time you will learn about secret scanning. Sit tight, get your DevOps brain working, and I would say, let's get started. Imagine that you're the administrator of a GitHub project involving several repositories holding the application codebase where the app interconnects with multiple external services. You would like to make sure that no credentials, keys, or similar secrets for those services get committed into the repository of the project. Luckily, your company just purchased a GitHub Advanced Security license that includes secret scanning, a GitHub feature that does just that. By the end of the video, you'll have learned what secret scanning does, how to configure it, and how to use it efficiently. So first off, what is secret scanning? As you can assume from the name, it is a component of GitHub Advanced Security, allowing to scan your repositories, the entire Git history across all branches for any secrets. Similar to Dependabot that we discussed before, it's basically super easy to configure. It's nothing more than 3 clicks and you're dramatically moving up the security and protection of your source code repositories. Secret scanning looks everywhere across your repos, looks in descriptions as well as comments of your issues, which might be active and closed ones. Next, it also checks details of each and every of your pull requests, as well as information in GitHub discussions. There's a screenshot here as an example. But hold on for more details in another live demo all the way at the end of the module. Now when you thought like, okay, cool, I get it, it scans for secrets. But do we need a full module to explain this? Well, I would say yes, we do. Because there's a few more things that makes it really powerful. For example, push protection. This allows you to not only scan and detect secrets which might have crawled up into your commits or they might already be stored in the repo. It actually blocks you from pushing or synchronizing the committed updates into a branch at all. So those confidential objects won't even make it into the repo anymore. While it depends a bit on the IDE you're using, the Git log will show you the exact details why the push is not working. And obviously, I'm going to show you that in my upcoming demo. Now you might wonder how secret scanning is able to detect those confidential keys, secrets, tokens. Well, there is a partnership with more than 50 different vendors like Microsoft, AWS, Atlassian, and so many more, allowing GitHub secret scanning to detect those values. But even better, it can also perform validity checks to see if the leaked credential is still active or ever was or maybe not anymore. While it's still leaked, the impact could be different. Last, a small warning I like to emphasize is that although secret scanning is enabled by default for all public repos, it's not the case for private repos. And then obviously you also need the GitHub Advanced Security license to be able to enable it. I already talked about the different vendors' credentials that are getting recognized and flagged by secret scanning. But that's not all. You can also create your own custom patterns, up to 500 per organization or enterprise, and up to 100 per private repo. I think that should give you more than enough flexibility to guarantee that almost any kind of secret string you want to find will get detected. The other details here on the slide on how to configure it, well, you can guess I'm going to show you that in my demo itself. Talking about demos, it's exactly my next slide here. So in short, I will show you where to find the secret scanning and then obviously how to enable it. From there, I'll show you how the alerts explain the details of what secrets it finds. And then next, I will show you how the push protection blocks a developer or DevOps engineer like yourself from pushing secrets as part of a commit action. So let me show you what secret scanning in GitHub Advanced Security looks like, where this demo will be a little bit shorter because it's only one little task, but I would say super powerful and actually extremely relevant and important to enable it. And just to make sure you get a good idea, I'm using a private repo. Now, why do I use a private repo in this case? Because in my demo environment, if I would create a public repo, well, as I talked about in the presentation, public GitHub repos have secret scanning enabled. So I needed to go through a little bit of a side path, you could say, to simulate my demo. Now, what is the starting point? Imagine I have my code on my local machine. I'm synchronizing with my GitHub repos, and inside my application settings JSON, my developer, in this case myself, stored a GitHub token. I'm not exposing any secrets per se, but technically I am, but this is a demo personal access token. So that's where I just want to make sure that I'm not overexposing information. But we made a mistake as a developer, you could say, where now we have this token from GitHub or any other vendor that I talked about listed in our code base. Now, to enable, I would need to go into settings. And again, if you do have the GitHub Advanced Security licensing, you would navigate to Advanced Security, where down here, you're going to find secret scanning. In my case, because again, I don't have enterprise or any organizations behind it, and I didn't want to focus too specific on enterprise capabilities only because I guess quite some of you viewing these videos are not just enterprise customers, I need to switch to public repo. So I'm going to move to the general section and then changing my visibility from private to public. I guess I need to provide some admin credentials. They were cached apparently, so that's positive. Well, now it's going to allow me to actually open up my security settings again. And now you can see down here that we do have secret protection. Now, if you create a public repo from scratch, it's automatically enabled. Since now I switched from private to public, it's not automatically enabled. So I'm going to enable this. Yes, I want to use secret protection, and on top of that, as explained in the presentation, I can also enable push protection. So I got my two options enabled, and from here I navigate to security secret scanning, and you can see that there is an immediate alert getting created like 47 seconds ago, basically once I enabled my secret scanning, and it's detecting the personal access token. It's in historical synchronized repos, you could say. So the big benefit is that once you enable secret scanning from a private repo or and switch from private to public and you enable it, it's going to look into your code base and immediately detecting it. Now, another thing that I want to show you here is that push protection, right? So for example, I go into my code base and gonna update any of my files, not too important. And I'm gonna add yet another secret using my demo key. When I now commit my changes, it's telling me here like, well, Peter, you cannot do that. Why not? Because secret scanning is detecting that secret. I can flag here it's being used for testing, it's a false positive, or it's okay, I know, I'll fix it later, which I think is not really according secret or security best practices. So what it means is that out of that push protection, it's now also blocking me from synchronizing. I showed you from within the GitHub portal, but in the end, if I would go back to my local development workstation, you inject the code or the key over there, trying to commit, that will work local, but then when I try to sync back to the repo, it will tell me in the git log errors that I cannot synchronize because of the secret scanning protection. So end-to-end, 100% secured, if obviously you enable not only secret scanning, but also the push protection. So with that, I'm going to wrap it up here and switching back to the last couple of things in our secret scanning module. The goal of this module was to help you understand how secret scanning works so you can configure and use it efficiently in your project. Remember, the feature is enabled by default on all public repositories and can be enabled at the organization or private repository level on an enterprise plan with that GitHub Advanced Security license. Also remember the nifty little extra setting for push protection, guaranteeing your secrets aren't even getting pushed into the repo in the first place. There are many ways to continue your learning journey. I encourage you to watch other videos in this course or search for your next favorite topic on Microsoft Learn using aka.ms/learn. I'm thankful for having you here learning about GitHub Advanced Security features. We're close, but not finished yet, since I have one more feature, and then maybe the most powerful one even, to explain, called CodeQL, which performs overall security code scanning. I'm already looking forward to meet you once more in the next module.